All right, today, Algebra 2, Lesson 77, we're going to talk about using the law of cosines. What we've already learned up to this point is using the law of sines. Law of cosines is going to be a little bit different. What we read here is that for a triangle that is not a right triangle, the law of sines can sometimes be used to find a missing measure. In fact, it can be used when given, sorry, that should be two, not toe. Sometimes I don't look up whenever I type. Okay, let's fix that there. Two. Finding given two angle measures, let's add an S in here, and a side length, or two side lengths and a non-included angle measure. So we've talked about using the law of sines in order to find either a missing side or a missing angle, right? So long as I have 3 out of the 4 bits of information, right, I should be able to find either a missing side or a missing angle, right? Okay. All right. Law of cosines is going to work a little bit differently. Law of cosines can be used other times, specifically in these two instances. One is whenever the measure of two sides and the included angle are known. So two sides and the included angle. So that's if I have a triangle like this, and I know, let's say, what this side length is, and I know what this side length is, and I know what this angle is, right? If I know those 2 bits of information, I have side angle side, I can find all the other missing parts, right? Okay, or I can find the missing parts if I know the measure of all 3 sides. And these are for non-right triangles. So if I know this guy, and this guy, I can find all the other bits of information. I can find all the other angles, okay? So we'll show exactly how that works whenever we get into this next slide. So the law of cosines works like this. All right, let's say I want to find side A, right? And the information that I know is over here, right? So I know what side B is, I know what side C is, and I know what angle A is. Okay, I can find that by plugging that information in here and square rooting that information to find the side length of A. Right? Let's say I know what side A is, I know what side B is, and I know what side C is, but I don't know what angle A is. Well, I'm going to plug all that information in here. I'm going to plug my side length for A, my side length for B, my side length for C, my side length for B, my side length for C, and I'm going to leave this open. And once I get all my information, I'm going to hit inverse cosine, and that's going to give me my angle measure. All right? Essentially, all of these are basically the same thing. Okay, they're just swapping out what information I have with what I'm looking for. Okay, and this will make a little bit more sense when we actually start to solve questions. All right, but you'll find this in your book, and so you want to be open to page 546 so that you can see that, because eventually, we're going to hit next, and we're not going to see this page anymore. All right. So this information is really important. We're going to work these problems out. It's going to be some longer looking equations, but they're not difficult. Okay? We're just squaring numbers, but this is our formula. So a squared equals b squared plus c squared minus 2 times b times c times cosine of angle A. Okay? Now, last bit of information is how we can find the area of a triangle in this situation. So an angle measure is not the only measure that can be found when 3 sides of a triangle are known. So just like what we saw, if I know the length of all 3 sides, even if it's not a right triangle, we can find the area using what is called Huron's formula. It can be determined when 3 sides of a triangle are the only measures that we're given. We're not given any angles. And so what we would do is we would take A plus B plus C. We would add those up, and we would divide by 2. Okay? And then what I would do is I would make the square root, and I would take this measure from down here, okay, this answer, and I'm going to say this answer times that answer minus the measure of A times my answer of S minus the side length of B times the measure of S minus the answer of C, and I would square root that whole thing, and it's going to give me the area of my triangle. Now, obviously, if we can ever do base times height divided by 2, that's the easiest thing to do, but sometimes we don't have all the information, okay? So this is just another way to take the information I have and still get where I want to go. All right? Are you going to have this memorized? Probably not, which is why this is showing up later in your book. You're not necessarily expected to memorize this, but I do expect you to write it down, put it somewhere where you can find it, so whenever we see, you're looking at a question in your future homework assignment that says, you need to find the area of this, and it says 77 underneath of it, right? Well, rather than going back to lesson 77, I should be able to go back to my notes, right, for lesson 77 real quick, find these formulas. Okay, does that make sense? All right, hopefully everybody's with me. All right, I know I'm talking pretty quick, but we had the grade 3 assignments today, so we don't have as much time. Let's look in here, and let's see if we can figure some things out. Okay, so we're going to use some real-world scenarios here. This one's kind of tough, okay, just as a warning. It says we've got island A is 220 miles from island B. A ship captain travels 230 miles from island A and then finds that he's off course by 150 miles from island B. What is his angle in degrees? What is the angle that he has to turn his boat in order to head straight for island B? Okay, so this seems like a really complicated question, right? We get stuck on something like this on a test. All right, so I'm going to try to draw this up here above it. All right, so we're starting out from island A, correct? Now, we already know that island B, let's say island B is right there. We know the distance from A to B, correct? What's the distance from island A to island B? 220 miles, okay? But for whatever reason, whether or not our compass breaks or whatever, there's some sort of storm and it knocks us off course, and we find ourselves heading out this way, okay? In fact, the ship captain travels 230 miles from island A, and island B was only 220 miles away, so we know that we're off course, correct? So what is where our ship's captain at is right here. What is the distance from A to what we'll call C? 230. All right? And we know that where he's at is how many miles from island B? 150. Okay, so we've got a triangle here. Does this make sense so far? Okay. Now the question that is being asked is how many degrees does he have to turn to get headed back to island B? Now this is what's confusing about this question. Okay? He is headed in this direction, correct? So the angle that we're looking for is not this angle, but this angle, okay? Because he has to turn and head back that direction, correct? He has got to get back on that line that is going to go from C to B, right? But in order for me to find this red angle here, I have to know the blue angle, right? Because what is this? If I draw a green line here, can anybody tell me anything about those two angles? What are they? What do they measure added up? 180 degrees. So if I find angle C, I would subtract it from 180, and that's going to give me the degrees that I have to turn, correct? Okay, now we're going to go back to our equation. What am I trying to solve for here? I'm trying to solve for angle what? C. Trying to solve for angle C here. Okay? So I'm going to use that third equation down, correct? So that third equation says C squared. Do I know what C squared is? Yeah, I do. Side C. What is side C? Can you tell me what side C is? 220, because it's opposite, right? Side C. What is side B? 230. And what is side A? 150. Okay? So our equation, I know I'm going to make a mess here, should be 220 squared equals what? 150 squared, right? We're just following the equation at this point, and you guys should be able to see that in your book, right? You are all looking at the third equation down. in the box on Law of Cosines on page 546, a squared plus what? 230 squared minus what? Times, well, let's keep it in order. Let's do times 150 times 230, right? Yes? Okay, times cosine of angle C, right? So I'm going to use this to find angle C. It'll make sense here in a little bit. All right, so you guys have calculators, correct? All right, so I want to hear these numbers called out. You guys should be able to do these pretty quickly. 220 squared. 48,400, I heard. 48,400 equals, let's see, 150 squared. 22,500 plus 230 squared. Let's go ahead and put that together. Is that 75,400? 75,400 minus, all right, now we will need negative 2 times 150 times 230. Negative 69,000, right? Okay, yeah, so you got negative 300 times 230. And it should come out to negative 69,000. Negative 69,000 cosine C. Now, what I want you to understand about this is that this is multiplication here. All right. So I can't combine 75,400 and negative 69,000. Right? They're not like terms. This would be the equivalent to 75,400 minus 69,000 C. Okay. So I can't group them. But what I can do is I can move 75,400 across because what we're trying to do is solve for angle C, correct? So I want to move everything away. So what's 48,400 minus 75,400? Negative 27,000. So I got negative 27,000 equals negative 69,000 cosine C. All right, so what do I want to do to get negative 69,000 over to the other side? Divide. So what's negative 27,000 divided by negative 69,000? 0.3913, right? Is that correct? Yes? No? Maybe? Okay. Equals cosine C. So what I'm going to plug in my calculator is inverse cosine 0.3913. (66.96 degrees). All right. 66.96 is not my answer. That's angle C. So what do I need to do with 66.96? Go back. This is 66.96 right here. Subtract it from 180. So 180 minus 66.96 equals what? 113.04 degrees. So if he needs to turn back to the left, 113.04 degrees to get headed back to his island destination. Now, I know that, you know, in a perfect world, computers and GPS will do all this for you. But, I mean, I'm not saying that you're ever going to be in a Bear Grylls situation where you're going to have to do this, but would it be feasible to use math to save your life if you were stranded out to sea and you had even just a little bit of information, right? If you knew how fast you were traveling and for how long, you could figure out that 230 miles, right? Right? You probably already knew before you headed out that you were 220 miles away, so you know that you're off course, right? Because you know probably, hopefully, what degree that you headed out at. You know that that's not correct, right? Or the wind was blowing you at such and such. So you could find a way to get back to where it was that you needed to go if you had enough information using math. Hopefully, you never get in that situation. All right. So we've got this answer. Come on, there we go. All right. Did you guys get that written down, hopefully? Okay. All right. So a lot of these are using this kind of scenario. You get a lot of word problems in here. Two airplanes leave the airport at the same time. We're going to represent the airport with a point that we're going to call A. Okay, does that make sense? One airplane flies due east at 300 miles per hour. Boom. Okay, the other airplane flies east, northeast at 350 miles per hour. The angle between the two directions is 22.5. So we can put a 22.5 degrees right there, correct? All right. Let's see. If the planes are at the same altitude, how far apart are they after 2 hours? So we're going to end up looking for this length right here, right? But the other information that we need is we need to know how far they've traveled in that time. The first plane was flying at 300 miles per hour. How far could he go in 2 hours? 600 miles, and that's this guy right here, correct? All right, the other guy was going 350 miles for 2 hours. How far did he get? 700. All right, so what we are looking for is this distance right here. So let's call this B. Let's call this C, which means what would I call that missing part right there? What's that side length called? A. What is 600 called? B. And what is 700 called? C. Okay? So we're looking for A. So which equation am I going to use? The first, the second, or the third there on that page? The first one, right? I need to solve A squared. I don't know what it is. It's going to equal what? Well, let's start in alphabetical order here. So it would be what? 600 squared plus 700 squared minus 2 times 600 times 700 cosine what? Which is 22.5, right? Does that make sense? All right, we don't know what A squared is, but we're going to take this information. Now, I want to show you something kind of neat, that I'm going to be able to get my answer all in one single shot. Because in the end, whatever my answer is going to have to be square rooted to get A, correct? All right, so let's do this instead. Let's go ahead and put all of this underneath the square root symbol. So 600 squared plus 700 squared minus 2 times 600 times 700. I'm going to check my mode here real quick. Good. Times 700 cosine 22.5. I'm going to close that parentheses, and I'm going to close the main parentheses set. We're going to hit enter. All right, let's round it to the nearest mile. So what does A equal to the nearest mile? 272 miles. Was that doable? All right. But I have to draw a picture first so that I get all my labels right, so I know which equation I'm using and how to plug those numbers in. Okay? So if I'm ever looking for this guy out here, I can square root the whole equation, get it in my calculator, and solve. All right. How many of you understand what's going on here pretty well? Feel like we've got a decent handle on it. Great. That's at least more than half. Okay? All right, number 3. Okay? A building has a triangular floor with side lengths 150, 200, and 280. So the first thing I'm going to draw is what? Triangle. Okay, Jose, what number would you put on the, like, maybe the left-hand side? So you're just going to put a 200. On the right-hand side? 150. And I'm guessing on the bottom 280, right? Okay. To the nearest square foot, what is the area of the floor of the building? All right, so am I using the law of cosines, or am I using a different formula? So we want to go back to Huron's formula, right? What's the first thing I need to solve for? S. How do I solve for S, Lexi? All right, so A plus B plus C divided by 2 would work also, right? So what am I adding up here? Okay, so 200 plus 150 plus 280 divided by 2, right? What does that give me for S? You already added them up, so have you divided by 2 yet? What did you get when you divided by 2? It's not what I got. You should get 315. So check your math again. 200 plus 150, so we got 350 there. 350 plus 280 divided by 2. Did you see your mistake? Okay. So we got S equals 315. All right, after that, area equals what inside the square root? What am I going to write? 315 times minus what? 200. It really doesn't matter because I'm going to do this 3 times, right? 315 minus what? 150, I heard. And 315 minus 280. Okay, so all of that. All right, so we can come back to our calculator. Let it do some of the work for us. We got the square root of 315 times 315 minus 200. Be careful of your parentheses here. Make sure that you're using them. I'm going to slide that over so I can see what I'm doing. 315 minus 150 times 315 minus 280. Okay, I'm going to close up both sets of parentheses. Does anybody have an answer before I hit enter? What did you get? What did you get? What did you get for your area? 14,464. I heard 2 people say. Anybody else get an answer yet? All right, I see a lot of people not plugging anything into a calculator. That is a big mistake, right? This is your opportunity to practice and make sure that you physically know what you're doing. And the best way to do that is to be doing it as we're doing it so that you're getting that practice, that kinetic, practice. So I'm going to hit enter here and see if I get their number. 14,460. And they want us to the nearest foot, so 14,464 feet squared. All right? You won't get any better by not practicing. All right, so we know how to find the area. 4. How many degrees is measure angle B? So we're looking for this guy right here. Which equation do I want to use, Corey? The first, the second, or the third? I'm looking for angle B. What'd you say? The second one. Okay, so help me out here. What am I going to write? 12 squared equals 5 squared plus 8 squared minus 2 times 5 times 8 cosine B. Excellent work. All right. So, because I'm looking for cosine B, this is not one of those that I can just plug in my calculator, right? I can't do this all in one shot. I actually do have to go through the process. What's 12 squared, class? 144. All right, 25 plus 64, right? What's 25 plus 64? 89. All right, so I'm going to go ahead and get that there. I've got negative 2 times 5 times 8. I bet that's what, negative 80? Negative 80. Negative 80 cosine B. All right, what's my next step? Subtract 89. Subtract 89. 25 times, or 25 plus 6. Okay, all right. I'm going to take your word for it. What's 65? 55. All right. Make sure here. You said 55? Okay, 55. 55 equals negative 80 cosine B. Okay. Let's see, what do I want to do next? divide by. All right, so what's 55 divided by negative 80? Negative 0. Let's take it to 4 decimal places. Negative 0.6875 equals cosine B. All right, this is where people kind of lose what to do, because we're not just going to hit cosine, right? What am I actually going to do here? Inverse cosine. Okay, negative 0.6875 equals what? 133.43, but we're going to get to the nearest whole number, which would just be 133 degrees. Okay? We feeling more comfortable with this? Okay. Let's see. We have 2 questions left, and we only have time to probably answer one of them. You guys have the option. Would you like to see number 5 or number 6 solved? Either find the area or find B. Which would you rather do? What? You want to find B? Yes? Okay. All right. So if we want to find B, we're going to do what? B squared, right? Yes? B squared equals, and I can do this pretty quick, 7 squared plus 10 squared minus 2 times 7 times 10 cosine 41. Right? Is this one I can plug in my calculator all at one time? Sure is. Anytime I have that. So what are we going to start off with here? I'm going to start off by typing what? Square roots. Very good. Square root. Okay, 7 squared plus 10 squared minus 2 times 7 times 10 cosine 41. Close up both parentheses, hit enter, and I'm getting to the nearest 10th. What is this? 6 to the nearest 10th, 6. B equals 6.6. The more that we do this, do we begin to see the pattern in solving these? Okay, great. Your answer for 6, if you work that out, should be 17. Okay. All right, we're going to hit stop right there.